This section is all about integrating using partial fractions. So you'll notice that all of these integrals in this example are fractions where you've got a polynomial on the top and a polynomial on the bottom. So let's look at A, and our first job with these types of questions is to write the fraction as partial fractions. So we know from the partial fractions chapter that we can write this fraction as A over x plus 1 plus b over x minus 2. And if we multiply through by the denominator, by that double bracket, we're going to have x minus 5 on the left hand side equals a x minus 2 plus b x plus 1. So there's a few ways that you can find the values of a and b. I'm going to use the method of substitution, but comparing coefficients would be equally valid. So I'm going to sub in x equals 2, and I'm doing that because that's going to ensure that this term here is equal to 0. So I'm going to get an equation just with b in it. So on the left hand side, if I sub in x equals 2, I'm going to get minus 3, and on the right hand side, I'm going to get 3b. So that tells me that b is equal to minus 1. And I can also sub in x equals minus 1, and I'm doing that because this bracket will be 0 when I sub in x equals minus 1. So on the left hand side we'll have minus 6, and on the right hand side we'll have minus 3a. So that tells us that a is equal to 2. So we can write our integral, or our integrand, as 2 over x plus 1, and then minus 1 over x minus 2. So our challenge now is to integrate these partial fractions. And the reason why this helps us is because now we've got two terms that we know how to integrate. So you don't need to do this, but you could split this up into two integrals. You could split this up into 2 over x plus 1 dx plus the integral of minus 1 over x minus 2 dx. And actually it doesn't matter whether you leave that minus 1 on the inside of the integral, or you could have the minus on the outside of the integral. So now we've got these two integrals to do. You might be able to do these by inspection by now, but if not, then you can go through the process of doing an integration by substitution. So if we were to integrate 2 over x plus 1 with respect to x, then we would use the substitution u equals x plus 1, and we would know that du over dx equals 1. So that tells us that dx is equal to du. So our integral would become the integral of 2 over u, and then we can replace dx with du. So that would just be 2 log of u, natural log of u. But u is equal to x plus 1, so we get 2 natural log of x plus 1. So we can replace this with 2 natural log of x plus 1, and we can do a similar thing with this integral. So with this integral, we want to work out the integral of minus 1 over x minus 2 dx, and we're going to let u be x minus 2, so that means that we're going to get du equals dx again. So our integral will be minus 1 over u, and we can replace dx with du. So if we integrate this, we're going to get minus log of u. But u is x minus 2, so we're going to get minus log of x minus 2. So here we're going to do minus log of x minus 2, and then we just need to add on our constant of integration, and this is our answer. And you could leave your answer like that, but often you'll get asked to combine it into a single log. So we could write this as log of, if we bring the 2 as a power, we could write that as log of x plus 1 squared, and minus log of x minus 2 plus c. And then you'll notice that I've got rid of the modulus symbol here because x plus 1 squared is always positive, but we need the modulus symbol here. So when you combine the logs, it's best if you just put a modulus symbol around the outside of your log, around the outside of what you're logging. So we can use the rule for when we subtract logs, and we can combine this into a single log. It's going to be x plus 1 all squared divided by x minus 2, because we've got one log, take away another log, and then plus a constant of integration. And we'll do the same thing for b. We're going to write this as partial fractions. And this is a little bit different because we've now got a repeated factor on the bottom. We've got an x minus 2 squared. So you need to remember that when we do that, one fraction will have x minus 2 squared in the denominator, and we're going to have another fraction just with x minus 2 to the power of 1 on it. And then we'll have a third fraction, which is 2x plus 1. So whenever you've got a factor squared, you're going to have two fractions from that factor. So we can times through by the denominator, so we know that 8x squared minus 19x plus 1 is equal to a. Now if we times through by the denominator, we're going to have 2x plus 1, and then times by plus b times by x minus 2, 2x plus 1, and then we're going to have plus c times by x minus 2 squared. So again, you can use substitution or comparing coefficients, it doesn't matter. I'm going to use substitution again. So the first substitution that I'm going to do is going to make the x minus 2 bracket 0. So I'm going to let x equal 2. And if we sub in x equals 2, on the left hand side we're going to have minus 5. And on the right hand side, this term will be 5a. And the other two terms will be 0 because the x minus 2 bracket will be 0. So this tells us that a is equal to minus 1. Next we could sub in x equals minus a half. And the reason why I'm doing that is because that's going to make the 2x plus 1 bracket equal to 0. So on the left hand side we'd have 25 over 2. And on the right hand side, every term with 2x plus 1 is going to be 0. So we're just going to have 25 over 4 times c, because this bracket here will be 25 over 4. So we can solve that to find c is equal to 2. And then finally, we could find b either by comparing coefficients or substitution. I'm going to use substitution again. So you can actually find b just by subbing in any other value of x. So I'm going to sub in just x equals 0 to make it simple. So if we sub in x equals 0, on the left hand side we're going to have 1, and on the right hand side we're going to have a minus 2b and plus 4c. So this is going to help us find b because we already know what a and c are. So 1 is equal to minus 1 minus 2b and plus 8. So we're going to get that minus 6 equals minus 2b. So b is equal to 3. So we know that what we're trying to integrate can actually be written as minus 1 over x minus 2 all squared, 3 over x minus 2 plus 2 over 2x plus 1. So now our challenge is to integrate these three terms, and we can do this by either by inspection or by substitution. So let's look at each term separately, and we're going to split this up into three integrals. So first of all, let's look at the integral of minus 1 over x minus 2 squared. So the substitution that we're going to use here is the part inside the bracket. So we're going to let u equal x minus 2. And if we do that, we're going to have the integral of minus 1 over u squared. And we need to replace dx with du. Well, here we've got that du is equal to dx. So that's just du. So if we integrate this, we're going to use the fact that 1 over u squared is u to the minus 2. So we can write this as minus u to the minus 2. And if we integrate that, we're going to increase the power by 1 and then divide by the new power. So we're actually going to get plus u to the minus 1. But remember that u is just x minus 2. So we're just going to get x minus 2 to the minus 1. So when we're writing down our integral, we can write that as x minus 2 to the minus 1. Next, let's integrate 3 over x minus 2. So again, we can do a u substitution. So let's say u is equal to x minus 2. So our integral is going to be 3 over u. And again, we're going to have du equals dx, because du by dx equals 1. So if we work this out, we can take the 3 out of the integral and we'll have the integral of 1 over u, which is just going to be ln u. So we're going to have 3 natural log of u. But remember that u is x minus 2. So we're going to have 3 natural log of x minus 2. And then finally, we can integrate this last term. We're going to have the integral of 2 over 2x plus 1. So we're going to say u is equal to the denominator, 2x plus 1. And so du by dx is equal to 2. And this tells us that dx can be replaced with a half du. So when we do our integral, we're going to have the integral of 2 over u times by a half du, and then the 2's are going to cancel, so we're just going to have the integral of 1 over u, which is natural log of u. But but u in this case is 2x plus 1, so we're going to get log of 2x plus 1. And then we need to remember our constant of integration.